All right, so let's look at all the odd numbered questions. So 7 squared plus 8 squared is equal to c squared. So 39 plus 64 is equal to c squared. So 113 is equal to c squared. So c is root 113. So I want sine of theta. So 8 over root 113. When I rationalize the denominator, I get 8 root 113 over 113. Cosine of theta is 7 over root 113. So that is 7 root 113 over 113. Tangent of theta is equal to 8 over 7. Cosecant of theta is root 113 over 8. Secant of theta is equal to root 113 over 7. And cotangent of theta is equal to 7 over 8. Okay. Number 3. So 7 squared plus 11 squared is equal to c squared. So 49 plus 121 is equal to c squared. So let's see. 170 is equal to c squared. Excuse me. 170 divided by... oh my goodness. I cannot write tonight. 8, 16... 10, 5, okay, well, it does not look like it's nice. No perfect squares come out of this. So, c is equal to root 170. Sine of theta is equal to 75. Nope, just kidding. That's cosine. 11. Nope. I was right to begin with. 7 over root 170. It has been a long day. 7 root 170 over 170. Cosine of theta is equal to 11 over root 170. So that's 11 root 170 over 170. And then tangent of theta is equal to 7 over 11. Cosecant of theta is equal to root 170 over 7. Secant of theta is equal to root 170 over 11. And cotangent of theta is equal to 11 over 7. Okay. Number 5. I'm looking for a different side length. So 8 squared plus b squared is equal to 11 squared. So 64 plus b squared is equal to 121. I'm going to subtract 64. So I get 57 is equal to b squared. 1, 3, 27. So that's also not going to be very nice. So b squared. So b is equal to root 57. So sine of theta is equal to root 57 over 11. Cosine theta is 8 over 11. Tangent of theta is root 57 over 8. Cotangent, nope, just kidding. Cosecant of theta is 11 over root 57, which is 11 root 57 over 57. Secant of theta is equal to 11 over 8, and cotangent of theta is 8 over root 57, which is equal to 8 root 57 over 57. All right, 7, we're given a triangle. We're given a theta. 3, 7, I'm going to find a. So a squared plus 3 squared is equal to 49. Well, I guess I could write it as 7 squared. 7 squared, so a squared plus 9 is equal to 49. A squared is equal to 40, so a is the square root of 40. So a is root 4 root 10. So a is 2 root 10. So I already have sine. I need cosine of theta. So cosine of theta will be 2 root 10 over 7. Tangent of theta is equal to 3 over 2 root 10, which will be 3 root 10 over 20. And then cosecant of theta is 7 over 3. Secant of theta is 7 over 2 root 10, which is 7 root 10 over 20. And then cotangent of theta is 2 root 10 over 3. So I did that rationalizing stuff in my head. So just so we're aware, here, 7 over 2 root 10, I multiply by root 10 over root 10. So I get 7 root 10 over 2 times 10. So that's where I get the 20 from at the bottom. All right. How many more questions do we have? I have 9, I have 11, I have 13, I have a lot. That's not too bad. All the way to 16, not bad at all. Could be a lot worse. Could be like the last section we just did. Okay, so let's do 9. Cosine. Theta, 5, 11, looking for b. So 5 squared plus b squared is equal to 11 squared, so 25. Plus b squared is equal to 121 minus 25. 6, 96. Maybe. Yeah. So b squared is equal to 96. So b is root 96. So 96 is divisible by 2. Well, it's also divisible by 3 too. So 4, 8, 1, 6, 8, 2, and 24. 2 and 12, 2 and 6, 2 and 3. So 1, 2. So then that is b is equal to root 16 times root 6. So b is 4 root 6. Okay. So now I got to do all the trig functions. Okay. So we did cosine. So sine of theta, 4 root 6 over 11. So cosecant of theta is 11 over 4 root 6. Rationalize my denominator, so I get 11 root 6 over 24. Cosine of theta we already did, so secant of theta is equal to 11 over 5. And then tangent of theta is 4 root 6 over 5. So cotangent of theta is 5 over 4 root 6. Rationalize my denominator in my head, so 5 root 6 over 24. 11. I was given tangent, so tangent is opposite over adjacent. So I'm looking for my hypotenuse. So 9 squared plus 5 squared is equal to c squared. So 81 plus 25 is equal to c squared. So 106 is equal to c squared. So c is the square root of 106. When I have 106, I divide it by 2. I get 53. And I don't think this is going to give me any perfect squares. No, I don't think it's going to give me any perfect squares. So just the root of 106. So I have tangent. I need sine of theta. So that is 5 over root 106, which is 5 root 106 over 106. And then, cosecant of theta is root 106 over 5. And secant, nope, just kidding. Cosine theta is equal to 9 over root 106. So that's 9 root 106 over 106. And then secant of theta is equal to root 106 over 9. Tangent of theta we already did. So cotangent of theta is 9 over 5. All right, so let's look at this question. So my theta is here. It's adjacent over opposite. So 11 squared plus 3 squared is equal to c squared. 121 plus 9 is equal to c squared. So 130 is equal to c squared. So 130 divided by 4, I don't think works out. Divided by 2, 6, 12, 10, 5. Divided by 5, 1, 5, 1, 3. Nope. Okay. No perfect squares. So C is root 130. So sine of theta is 3 over root 130. So that is 3 root 130 over 130. Cosecant of theta is root 130 over 3. Cosine of theta is equal to, 11 over root 130, which is 11 root 130 over 130. And then secant of theta is equal to root 130 over 11. And then tangent of theta is equal to 3 over 11. All right. All right, 15 is the last one. Theta 23 is my hypotenuse. My opposite side is 9, so I'm finding a squared plus 9 squared is equal to 23 squared. That's going to require some effort. Okay, so I have a squared plus 81 is equal to 529. And I'm going to subtract 529 from 81, and I get 448. So a squared is equal to 448. So I'm going to divide this by 4. So a squared is root 4. I can divide it again, so that I get root 4 again, and I get one more root 4 and then a root 7. So a squared is equal to 8 root 7. So I have cosecant, so sine of theta is 9 over 23. Cosine of theta is 8 root 7 over 23. So secant of theta is equal to 23 divided by 8 root 7. So that's 23 root 7 over 56. And then tangent of theta is 9 over 8 root 7. So that's 9 root 7 over 56. And then cotangent of theta is 8 root 7 over 9. All right, and that's it for all the odd number questions.